Okay, so we have here a resistive touchscreen that I built at home. We'll demonstrate in a moment how it works and what we can use it for. But it's pretty simple stuff. It's just two sheets of plastic that are connected with metal conductors. And yeah, let's demonstrate and see what it does. As you can see, there's 4 different colors. Each time I press on a certain color, the red LED should turn on. So let's see if that works. For demonstration number 2, we'll take out the color slide and we'll put in the letter slide. Okay, so again, you could think of this piece of paper as just an LED display on a smartphone or computer, and it just shows the user what to press. It has nothing to do with the touch itself. So we have S, D, A, and H, and I'm going to spell the name Hadassah. There you go. So again, a touch screen that I made at home that we could actually write text on it that will show up on the computer. To explain how this type of touchscreen works, let's take it apart and see what's inside. Now inside, you see that there's just 2 sheets of plastic, okay? 2 sheets of plastic. Now these are special sheets of plastic because they conduct electricity. Most plastic does not conduct electricity, but these are coated with tin oxide, which is a conductor, but it's clear, so it conducts electricity. So just to demonstrate that, we'll put on resistance, and you can see that there's resistance, meaning electricity could go through. There's around 1.5 kilo ohms of resistance, but still electricity could go through. Most plastic, electricity cannot go through at all. Okay. Now the idea of how this type of touchscreen works is that we connect 2 pieces of metal, okay, on 2 sides. So let's connect 2 pieces of metal across. So this will be our positive side, and this will be our negative side. Okay. So let's hold them down. And because it's coated with tin oxide, which is a conductor, so current will go through. And if current goes through and there's resistance, there'll be a voltage drop, right? You know that from Ohm's law. So if here we're at the the positive side, and we'll see we're around 4.3 volts, right? Once we go on the plastic, we're around 3. As we start moving towards the negative, you could see on the multimeter that the voltage goes down, right? So if we want to know, for example, the x-axis, each point on the x-axis will only have 1 voltage, right? If you go up and down right on the y, it shouldn't make a difference, right? So every point should have only 1 voltage, okay? So if, let's say, we want to know the x-axis, we check and we see, hey, how much volts is it here? Let's say 2.7. Okay, so we know the x-axis. We still don't know the y-axis. It could be anything on the y line, right? So then what we would do is we would put, electricity across on the y-axis. Okay, so let me just hold that down. And we would find, so again, if this was the x, which we already know is 2.7, and then on the y-axis, say it was here, right? Oh, it's it's 1.3, right? And also here, if we're closer to the top, right, there'll be more of a voltage, right? And as we make our way down, you see there's a voltage drop. So the long and short of it is that the microcontroller, we have 4 of these wires for the x and y, and the microcontroller will measure the x first and determine what the position is, and then it will check the y and determine the position, and then we have an exact position because we'll know an exact x and an exact y. So that's the long and short of it. Now the piece that goes on top is really just like a probe, okay? So it's not touching, and the second it touches, okay, and it's connected to the microcontroller, wherever you touches that point underneath, and that is the voltage of where you're touching. So again, we'll first check the x, and then a moment later we'll check the y.